Okay, so now we're going to be looking at a new equation. Let's say we have x squared plus 4x plus 4 equals 0. Now, we want to make the equation true, so we need to find a value of x that will do so. You might think we can just input 0, and that would make, because anything multiplied by 0 becomes 0, so 0 squared plus 4 times 0 is still 0. Then you also have to realize that we're adding it by 4 again, which will not make it 0. So let's first identify what this is. This is actually known as a quadratic. And quadratics cannot be it must be factored in a specific way. They must be solved in a specific way. Quadratics can be written as, so let's say we have this equation in this instance. We have x plus a times x plus b. That's how we factor it. And a and b are constants that we have to find. So how do we do this? Well, the way we actually expand quadratics, as I may have mentioned earlier, is you multiply these two, then multiply these two, then multiply these two, and then multiply these two. So essentially, if we were to do that here, it would become x squared plus bx plus ax plus ab, which would be simplified to become x squared plus a plus bx plus ab. And this is supposed to be equal to this. So we can see that the coefficient of x in this case over here is 4. But here it's a plus b. So we can say a plus b is equal to 4. And then over here the coefficient of nothing, there's no x here, so it's just the constant here is ab, but over here it's 4. So that means ab equals 4. And we have to find values that fit that. So, well, we can say that we have to first find the factors of 4, which would be 2, 4, and 1. And we have to find two values that add up to 4, but multiply together to get 4. Well, in this case, we can see that multiplying this by itself, 2 times 2 will give us 4, and 2 plus 2 would give us 4. So we can write this now, subbing in the values of a and b as x plus 2 times x plus 2. Now, we still aren't done here. We have to make this equal to 0. How do we do this? Well, we find a value of x that will make this expression alone, not this expression, equal 0. And for this, that would be -2, because if you make any of these expressions 0, then since they're multiplied together, 0 times anything is still 0, so that would make it 0. So if you substitute -2 in here, -2 plus 2 is 0. So that works. Over here, same thing. -2 would also be substituted here to get 0. So our only solution is actually x equals -2. And we can check that this solution works. When we substitute x equals -2 in there, let's check it. So -2 squared is 4. 4 plus, and then 4 times -2, which means it's 4 minus 8, which is equal to -4. But then we're adding 4 again, so that equals 0. So it works. But notice that we can actually write quadratics as ax squared plus bx plus c. And in this case, a would be 1 because there's no the coefficient of x squared is just 1. B would be 4 because the coefficient of x is 4, and then the constant c is equal to 4. But what if we have a value of a that is not equal to 1? What if we have 2, wait, let me just write that down, 2x squared plus 5x minus 4. Let's say we had something like that. How would we solve it? Well, if we are looking at it in the factor term, that would actually be 2x plus a, x plus b. Why, you might be wondering, why do I have 2x here instead of just x? Well, it's because we have a 2 here now. And the only way we can obtain the coefficient of x squared is multiplying the first term here, multiplying the two terms that have x in it. You can't multiply the two constants, they won't give it the value of x. And multiplying the other terms will give you only a coefficient of x. It won't give you x squared like multiplying these two would give, because x times x is x squared. So we can expand this to get 2x squared plus 2bx plus ax plus ab, which can be simplified to give 2x squared plus 2b plus ax plus ab. But whoa, we have another problem here. It's 2b plus a, not a plus b anymore. So that makes it a bit more complicated. We can look at the factors of -4, but in this case, since I just picked a random one, there's no point in doing that. But essentially the two equations would be 2b plus a is equal to the b value over here, which means it's equal to 5. And then AB is equal to negative 4. So essentially, the thing that we need to recall is that we need to find two values. We need to establish two equations, simultaneous equations, and solve for them. Usually we can just do it by inspection, but in this case, we can, like in some cases, like the first equation, x squared plus 4x plus 4, we can just do it by looking at it. Like, oh, 4 has factors 2, 4, and 1, and 2 plus 2 is equal to 4, and 2 times 2 is equal to 4. In this case, since I just made it up, there's no point trying to solve it because it might not even be solvable. However, there is a much easier way of solving these kind of quadratics, and I'll show you that right now. Okay, so we've got an equation up here. It says x equals, in the numerator it says negative b plus minus root b squared minus 4ac, and then the denominator it says 2a. So you might be wondering, what on earth is this? Like, it just randomly appeared? Well, this is actually known as the quadratic formula. So let's take our original, like, general equation for quadratics. Ax squared plus bx plus c equals 0. And a, b, and c are all constants. It can be positive or negative. Now, over here, they make it pretty easy. B can be linked here, a, and c. So they're all being used to determine the result. But they don't find it in factored form. They actually just find the actual solution, so they go one step ahead. So let's take our equation, let's take an equation like 3x squared plus 4x, and then let's do plus 1 is equal to 0. So in this case, we've got 3 as our, instead of 1 as the coefficient of x squared. So it's going to be pretty annoying to have to solve this with our inspection method. So this is a more time-consuming method, but it at least gets the answer. So in this case, we can say that a is equal to 3, b is equal to 4, and c is equal to 1. And now let's substitute into the quadratic formula. So x equals, and then negative b, so it's negative 4, plus minus root, and then it's b squared, so it's 4 squared, minus 4, then times a, which is 3, times c, which is 1. And that's divided by, and then 2 times 3. So let's simplify that further. That's negative 4 plus minus root 16 minus 12 over 2 times 3. And we can go further than that to get negative 4 plus minus, and then it's basically root 4 here, because 16 minus 12 is 4, which is 2, over 6. And this is where there are two solutions. So the plus minus means that it can be either plus or minus. So let's say it's plus in this case. And negative 4 plus 2 is negative 2. So it's negative 2 over 6 is one solution, which is equal to negative 1 over 3. And the other solution is if it's minus. So minus 4 minus 2 is minus 6. So it's equal to minus 6 over 6, which is equal to negative 1. So our two solutions of x are negative 1 over 3 and 1. Negative 1, sorry. Let's say, though, we wanted to put this into factored form. Well, the way we do this is first, the first one would be obviously x plus 1, because putting negative 1 in here would make that 0. But the other one would be a little bit less obvious, because there is a 3x over here. So that means it would be 3x. There's a 3x up there. 3x is the coefficient. It is 3x equals ax. So 3x squared equals ax squared. And so 3x would have to go here, because then you're going to have to multiply this to get the coefficient of x squared, and so on. And we also have to realize that we need to get, since our equation is 3x squared plus 4x plus 1 is equal to 0, we need to multiply this by constant b to get 1. So that means that this value over here is 1. So it becomes 3x plus 1. So let's just erase that and write that down. 3x plus 1. So our factored equation is this. How can we check, though, that this actually works in here? Well, if you put negative 1 over 3 times 3, that becomes negative 1. Negative 1 plus 1 is equal to 0, so it works. This is a factored equation. And this will work for any type of equation. Let's take our form again of ax squared plus bx plus c is equal to 0. Let's say a was 4. Well, you might be thinking, oh, it's just 4x plus a x plus b is equal to 0. Well, no, it doesn't have to be, because 4 can be factored into 2 and 2. So it could be 2x plus a, and then 2x plus b. And then if you have larger numbers, like maybe like 12, it could be 4, 3, 6, 2. It could be any of the factors being the coefficient of x as long as they multiply to give 4. And that would become very confusing, because with our inspection method, that would mean that we would have to figure out, we would have to like trial and error every combination. That would become messy. The quadratic formula for sure gives you the solutions, and then you can put it into factored form by seeing how would you make that 0? What would you add or subtract to the solutions over here to make them 0? So yes, this is a quadratic formula. It works for any type of quadratic. And another thing to note is that if b squared minus 4ac over here is less than 0, that means that there are no solutions to the quadratic. So let's say that we have 4x squared plus x plus 10, and we wanted to factor it. Well, if we check b squared minus 4ac, so b in this case is 1, and a equals 4, and c equals 10. In this case, it would be 1 squared minus 4 times 10 times 4. Which is definitely less than 0. It's a lot less than 0. Which means that there are no real solutions, because anything in the square root of negative number is not real. So that means there are no real solutions to this. There are no real solutions to this. This cannot equal 0. And let's say if b squared minus 4ac is equal to 0. That means there's only one solution, because over here the plus minus then wouldn't matter. It would just be plus minus 0, which is just 0. So let's take an equation like 4x squared plus 4x plus 1. And let's take an equation like that. Well, b is 4, a is 4, and c is 1. So it'd be 4 squared minus 4 times 1, which is equal to 0. And logically, we can actually factor this to give us 2x plus 1 times 2x plus 1, which means it's a square. So we can really write this as 2x plus 1 squared. That's why this quadratic formula is really helpful. It can this part under the square root is known as the discriminant, and it tells us how many solutions there are. If it's greater than 0, that means that there's more than one solution. There are two solutions. If it's exactly 0, that means there's one solution, and if it's less than 0, that means there are no real solutions. There are definitely non-real solutions, but we don't cover that in IGCSE, just so don't worry about them too much. And it's useful for proving a lot of things. So yeah, that's quadratics for you. That's how you can solve for them. And so if inspection doesn't, typically I would use inspection only if the coefficient of x squared is 1, because then it's really easy to identify it. But I would use the quadratic formula if it's anything more than that, because then that would even check if there are any real solutions to begin with. It's a surefire way of getting the right answer. It's a little bit more time consuming, but it's definitely worth it if you want to make sure that you've got the right answer. Alternatively, you could use inspection and then check your answer with the quadratic formula afterwards, just to make sure that you've done it correctly. So this is most likely to come up in a CIM paper. It's also going to come up in an ad math paper. They won't ask you to solve for a quadratic. They'll just ask you a question, and you have to apply quadratics when necessary. So if you get a quadratic, always set it to 0. Bring everything on this side of the equation over to that side so that this is equal to 0. And then that way you can factor it and find the solutions. So yeah, those are quadratics. Thanks so much for watching. I'll put some worksheets in the description. And yeah, on to the next video.